Picture this. You're walking through this really dense, lush forest, right?
Oh, nice.
Yeah, right at twilight. The sun is just starting to dip below the horizon. The air is thick. It's warm.
That's a mood for sure.
Exactly. And
Mm.
all around you, this whole evening symphony is just tuning up. You hear the high rhythmic chirping of crickets hiding in the tall grass.
Right.
Down at the water, there's this deep, resonant chorus of frog croaks. Up in the canopy, maybe a few late birds are calling out with these intricate melodic trills.
It's beautiful.
It is. You stop, you close your eyes, and you just take it in. And you think to yourself, wow, that is genuinely beautiful.
Yeah, we all do that.
Right. Because we humans naturally find these soundscapes pleasing. I mean, they relax us, they inspire our music. We literally buy sound machines that play these exact noises just to help us fall asleep at night.
Guilty as charged. I have one on my nightstand.
Same. But here's a strange, highly intriguing question for you to consider.
Okay, hit me.
When you hear that frog croak and you think it sounds good, does the frog agree with you?
Oh, man. That sounds like the setup to a philosophical riddle.
It really does. But it's a real scientific question. Do humans and animals actually share the exact same taste in what sounds good?
It's such a wild concept when you actually stop and think about it.
It really is. So welcome to the Deep Dive Lab, everyone. Our mission for this deep dive is to investigate a century-old hunch about the universal nature of beauty.
It's a big one today.
Yeah, we are exploring whether our modern human playlists have way more in common with, like, a muddy swamp than we ever realized.
And we have a really phenomenal stack of source material to guide us through this investigation today.
We do. So think of the premise this way. Animal mating calls are essentially nature's version of modern dating app profiles.
That is a very accurate way to put it.
Right. I mean, they are carefully constructed, highly specific signals designed for one single thing to attract a mate of the same species.
Yeah, you're putting your best foot forward, or your best croak, as it were.
Yeah.
Exactly. A male bird sings a specific song, hoping a female bird of his exact species will metaphorically swipe right.
Right.
But the mystery we are diving into is whether an entirely different species, meaning, you and me, humans, would swipe right on the exact same acoustic profiles.
And to really grasp the weight of this question, we have to go all the way back to Charles Darwin.
Oh, we're going back to the heavy hitters.
We have to, because beyond his foundational work on natural selection, survival of the fittest, he also wrote extensively about sexual selection.
Right, the whole peacock tail thing.
Exactly. And in his 1871 book, The Descent of Man, Darwin proposed what was, at the time, just an absolutely wild idea.
What did he say?
He suggested that some animals might, and this is a quote, have nearly the same taste for the beautiful as we have.
Wait, he actually used the word beautiful to describe animal perception?
He did. He wasn't just saying they process sound mechanically like a robot. He was suggesting a shared aesthetic sense across the entire animal kingdom.
That is a massive claim to make in 1871.
Yeah, huge. And if we fast forward to modern biology, scientists have known for a long time that animals use sounds and colors and smells to attract mates.
Right.
We also know that the receivers of these signals, which is usually the females, they have highly tuned preferences for certain variations, like a slightly deeper croak or a slightly faster chirp.
Well, yeah, because mating with a robust, healthy member of your own species means viable offspring. That's just the baseline of good evolutionary business.
Exactly. But beyond just species identification, those preferences often emerge from what evolutionary biologists call sensory biases.
Sensory biases. Okay, break that down for me.
It's a really fascinating mechanism. So imagine a female insect whose auditory system evolved to be hypersensitive to a very specific low frequency.
Okay.
But she didn't evolve that to hear mating calls. She evolved it simply so she could hear the wing beats of an approaching predator.
Oh, wow. So it's purely a survival trait.
Pure survival.
No.
But eventually, the males of her species, over thousands of years, they evolved to sing at that exact same low frequency.
To hijack her attention.
Exactly. They hijack her pre-existing auditory attention. The sensory pathway existed for survival, but it gets completely co-opted for attraction.
Okay, I have to push back here.
Go for it.
Because it makes total evolutionary sense that a female frog's auditory system is built to process a male frog's song. It's like an internal closed-loop system for that one specific species.
Right.
But why would a human brain care? I mean, our hardware is completely different.
It is very different.
Right, a frog's ear is basically just a little tympanic membrane sitting right on the outside of its head.
Right.
We have this elaborate, spiraling inner ear nautilus shell connected to a massive mammalian neocortex.
Yeah, we're working with way more computing power.
Exactly. So why on earth would our highly complex brains process a frog's mating call and land on the exact same definition of attractive? We aren't trying to mate with frogs,
Thankfully.
right? And we don't share their predators. So the whole sensory bias thing shouldn't apply to us.
You are hitting on the exact barrier that stalled this entire field of research for decades. Yes. What you're pointing out is exactly why testing Darwin's hypothesis was so incredibly difficult.
Because we just don't have the same biology.
Well, it's easy enough to observe that a female bird consistently approaches a specific male bird's song in the wild. You can just watch her do it.
Sure, you track the behavior.
But how do you scientifically ask a human being to rate an insect's love song without completely anthropomorphizing the data?
Oh, I see. You can't just ask a person, hey, do you think this cricket is sexy?
Exactly. For over a century, the data was locked inside the subjective experience of each individual species. There was just no translation matrix.
Until now.
Until now. This is where the investigation takes a massive leap forward.
Yes. Enter Dr. Logan S. James and a team of brilliant researchers.
They're from McGill University, the University of Texas at Austin, Yale, and a few other heavy-hitting institutions.
Right. And they recently published this major study in the journal Science that finally figured out a methodology to test Darwin's 150-year-old aesthetic hypothesis.
The breakthrough was really in their approach, because they realized they didn't need to teach humans to interpret animal behavior.
Thank goodness.
Yeah. They just needed a massive cross-cultural data set and a remarkably simple question. So they created this online, gamified citizen science experiment.
Called the Music Lab.
Yes, the Music Lab.
And the scale of this is what makes the data so compelling to me. They gathered 110 pairs of sounds produced by 16 different non-human species.
That's a huge variety.
It is. We're talking birds, mammals, frogs, and even insects like crickets and fruit flies.
Fruit flies have mating calls.
They do. It's like a tiny little buzzing vibration.
Wow.
And then over 4,100 humans from all around the world logged online to participate.
That is a massive sample size.
Right. So imagine yourself sitting at your computer. You log in, and you see two little green silhouettes of a frog on the screen.
Okay, I'm picturing it.
You hear sound A, then you hear sound B. And the prompt on the screen simply asks, which call do you like more?
Very simple.
Yeah, you just press the F key for one or the J key for the other. It's entirely gut instinct. You don't overthink it.
And the crucial part of this methodology, the really genius part, is that for every single pair of sounds played to a human, the researchers already knew which sound the animal itself preferred.
Oh, that's the kicker.
Yeah, they had decades of prior field research documenting the more attractive sound in the wild for each specific species.
So the trap is set. We know what the female frog considers to be peak acoustic attractiveness. Now we get to see what a random human sitting at a laptop in a coffee shop thinks.
Exactly. And the findings were an absolute revelation.
What did they find?
Humans agreed with the animals across the board.
They really did. It's wild. Let's get into the mechanics of this because the examples in the science paper are just fascinating.
Yeah, the túngara frog is a perfect case study here.
Yes. Okay, so male túngara frogs, they can produce two distinct types of calls. They can make a simple call, which is essentially just a sweeping whine.
Just a single long sound.
Right. Or they can make a complex call, which is that exact same whine, but followed by an acoustic adornment that sounds like a distinct chuck.
A chuck.
Yeah, so it's whine chuck.
Oh, I see. It's a vocal embellishment, like a little extra acoustic flair at the very end of the sentence.
Exactly. It's the flare. And female túngara frogs aggressively prefer the flare.
They like the chuck.
They love it. When given the choice in the wild, they choose the complex call over the simple call about 84% of the time.
Wow, that is a 5-to-1 preference ratio. That's not subtle.
Not subtle at all. So what happened when humans in the music lab heard those exact same two calls?
The humans preferred the adorned calls, too.
Yes, we like the chuck. But why? I mean, what makes a frog chuck acoustically appealing to a human mammalian brain?
Well, it really comes down to the physics of the sound.
Okay, break out the physics.
So a normal frog whine is just a simple, continuous tone. It's pretty flat, but that chuck is what acousticians call a broadband burst of sound.
Broadband burst.
Yeah, it basically means it covers multiple frequencies simultaneously. It introduces a sudden, really sharp contrast to that flat whine.
Oh, okay.
And to a mammalian auditory cortex, just like to an amphibian auditory system, that sudden burst of acoustic complexity is highly stimulating.
It wakes the brain up.
Exactly. It tickles the neural pathways because it's so rich in nonlinear harmonics.
So it's acoustically richer, like hitting a full complex chord on a piano instead of just holding down a single key.
That is a perfect analogy.
Your brain is just getting more data, so it flags it as more interesting.
That is the precise mechanism. And what's crazy is it wasn't just an isolated incident with one specific frog.
Right, they tested 16 species.
Yeah. And the researchers found that the strength of human preferences actually correlated directly with the strength of the animal's preferences.
Wait, really?
Yes. If an animal had a robust, undeniable preference for a specific sound in the wild, like that 5-to-1 frog ratio,
Yeah.
humans were significantly more likely to choose that exact same sound.
That is wild.
And they found no statistical differences in agreement across the major animal groups. Humans agreed with the birds, the frogs, the mammals, and even those little fruit flies and insects.
And the researchers didn't just look at what people chose.
Right.
They also measured how fast people were clicking the keys.
Oh, yes. The reaction time data is such a beautiful piece of the puzzle here.
It really is.
On average, humans answered 51 milliseconds faster when they were choosing the sound the animal also preferred.
51 milliseconds. I mean, that is a fraction of a blink of an eye. You aren't sitting there pondering the artistic merit of the frog call,
No, not at all. It's completely subcortical.
meaning it's below conscious thought.
Exactly. In cognitive science, a 51 millisecond difference is massive. It indicates that the brain is completely bypassing any analytical conscious decision-making.
It's just reacting.
Yes. Your auditory processing centers are analyzing the harmonic structure of the sound and flagging it as preferable before your conscious mind even registers why you like it.
Wow.
It is an intuitive, deeply ingrained neural response.
It's like your brain hears it and instantly goes, yep, that's the good one.
Exactly.
There was another detail in the sources regarding evolutionary history that just completely blew my mind.
Oh, about the crickets.
Yes. The researchers looked at crickets. And crickets have these ancestral chirps that have been around for millions of years.
Right, the classic cricket sound.
But some species have recently evolved to make more of a continuous purr sound instead.
Okay. And what did the listeners think? Well, both the crickets themselves and the human listeners strongly preferred the ancestral chirps over the recently evolved purrs.
So we like the classics.
We really do. It implies that these baseline acoustic preferences possess an incredible evolutionary inertia.
Meaning they don't change easily.
Right. They're deeply entrenched in the biological blueprint of hearing itself.
So humans prefer the vintage cricket tracks to the modern remixes.
That's one way to put it, yeah.
Now, this raises a really fun question for me.
Okay.
If humans share this aesthetic sense with animals, are certain types of humans better at it than others?
Oh, that's a great question. Who's the most in tune with nature?
Right. Because if you ask me to guess, before reading this study, I would have bet real money that bird watchers or ecologists or maybe zookeepers would be the absolute best at this.
Sure, people who spend their lives listening to animals.
Exactly. Or, failing that, trained expert musicians.
Yeah.
People with highly developed ears for pitch and tone.
It is the absolute most logical assumption to make.
Right, but the data just completely shattered that assumption.
It really did. Being an animal expert, like a birder who spends decades identifying species by their calls in the wild, gave zero statistical advantage in agreeing with the animals.
None at all.
And being a professionally trained musician, someone who plays the violin for a major symphony, also provided no advantage.
That is so counterintuitive. So what was the variable? Who actually did the best?
The single characteristic that actually predicted if a human would agree with a frog or a cricket was how much time they spent passively listening to music every day.
Okay, I have to challenge that.
I knew you would.
Because, if I spend 3 hours a day listening to synth pop or heavy metal or, hip hop on my headphones, absolutely none of those tracks sound like a fruit fly buzzing.
No, they definitely do not.
So how is that passive listening translating into agreeing with a frog in an experiment?
It all comes down to how your brain processes acoustic complexity.
Okay.
The researchers suggest that it's not about the technical mechanical skill of producing music.
Which is why the professional musicians didn't have an edge.
Exactly. It's not about playing the notes. It's about the cognitive act of sustained auditory tracking.
Auditory tracking.
Yeah. If you are a heavy music listener, your auditory cortex is constantly getting a workout and separating different layers of sound.
Oh, I see.
You are subconsciously tracking a pulsing bass line, a vocal melody, and a hi-hat rhythm all at the exact same time.
Ah. So you're essentially training your brain to recognize harmonic intervals and acoustic geometry completely, regardless of what instrument or what animal is making the noise.
Yes, you're building up your auditory discrimination.
So it's like going to the gym for your ears.
That's exactly it. By consuming music heavily, your brain becomes highly attuned to subtle variations, rhythmic patterns, and acoustic contrast.
Wow.
Because the vocalizations of animals actually share a lot of fundamental acoustic features with human music, your daily Spotify habit is inadvertently keeping your brain super sharp for the universal rules of acoustics.
That is incredible. You are literally priming your neural pathways to recognize the underlying geometry of what makes a good sound.
Exactly.
Okay, but I want to zoom out for a second and look at the bigger picture here.
Sure, let's zoom out.
Because we were talking about frogs and crickets and pop music, but why is this more than just a really fun science fact you bring up at a dinner party? What does this actually mean for our understanding of the world?
Well, if we step back, this study provides massive empirical evidence for form-function relationships in acoustic signals across the entire animal kingdom.
Form-function relationships, meaning the actual shape of the sound is permanently tied to its biological purpose.
Yes.
Like, if you think about a fire alarm or a baby screaming in distress,
Right.
they both share that really harsh, jagged, rapidly changing frequency. It's what acousticians refer to as roughness.
Roughness, yeah.
And our brains, and a dog's brain, and a bird's brain are all universally hardwired to just hate that rough sound.
Because its biological function is to trigger panic and alert us to danger.
Exactly.
Spot on. Science has known for years that acoustic ugliness is universal because the need to detect danger is universal. Roughness serves a very specific evolutionary function.
Right.
But what Dr. James and his team proved with this research is that the exact opposite is also true.
The universal positive.
Yes.
Attraction is also universal.
Exactly. Attractiveness and beauty in sound are not arbitrary.
They aren't just random preferences.
No. There are specific acoustic forms like those harmonic bursts we talked about, or clear rhythms and pleasing frequency sweeps that serve the biological function of attraction. And our human brains are fundamentally wired to recognize and reward those forms, even when the sound wasn't engineered for our species at all.
That completely forces a perspective shift on how we view human culture.
It really does.
Because we tend to view human speech, and especially human music, as these isolated, highly advanced inventions.
Right, like we came up with them all on our own.
Exactly.
Yeah.
We like to think we invented the concept of a beautiful melody in a vacuum, completely separate from the animal world.
But we didn't.
No. This means the acoustic preferences that shape our chart-topping hits are actually deeply rooted in an ancient shared biology.
It completely shatters the illusion of human exceptionalism in aesthetics.
Human exceptionalism.
Yeah. We aren't the sole arbiters of beauty. We are simply tapping into this primal acoustic web that has existed for millions of years.
That is so profound.
And the real-world implications of understanding this are actually vast.
Oh, I'm sure.
Yeah.
Because if we know the universal rules for what a biological nervous system finds attractive or calming, the applications are basically endless.
Think about how we design audio technology.
Right. We could engineer much better user interfaces.
Yeah.
Or, less abrasive public address systems.
Yes, or even smarter artificial intelligence voices.
Oh, that's a good point. Instead of tech companies just guessing what sounds pleasant to a user, they can design audio based on millions of years of evolutionary consensus.
That's a perfect application. And it also extends deeply into medicine and therapy.
How so?
Well, if we are utilizing sound therapy to lower a patient's heart rate, or maybe reduce severe anxiety in a clinical setting,
Okay.
we could specifically employ these fundamental acoustic forms that inherently signal safety and attraction to the mammalian brain, rather than just playing generalized ambient noise or ocean waves.
This is a targeted neurological response.
Exactly. Furthermore, it provides this profound new lens for ecologists.
Oh, for conservation.
Yes. When conservationists protect a habitat, understanding the acoustic environment, how different species interact with the underlying geometry of each other's sounds, it adds a really vital layer to protecting biodiversity.
You aren't just protecting the trees and the water. You are preserving the acoustic web itself.
Beautifully said. Yes.
You know, when you put all these pieces together, it really makes you rethink your next walk in the woods.
It definitely changes the experience.
You aren't just this alien observer walking through their world anymore. You are actively participating in the exact same sensory experience they are.
Right.
When you hear that bird sing and you think, that's lovely, the bird is essentially operating on the exact same acoustic wavelength as you.
Darwin would be so thrilled by this outcome.
He really would be.
It is the ultimate vindication of his 150-year-old hunch. He looked at the displays of nature and he dared to suggest that aesthetics weren't just a human luxury, but a true biological constant.
And he was right.
He was right. And there is a specific realization from the authors of this science paper that summarizes this so beautifully.
What do they say?
They noted that much of the beauty we find in nature was intended for receivers other than ourselves. That frog is not singing for you. They're communicating with their own kind in a desperate evolutionary bid for survival.
Right.
Yet, despite being entirely outside the intended audience, our brains are wired to appreciate it anyway.
It's like accidentally intercepting a love letter meant for someone else and still being completely moved to tears by the poetry of it.
That's exactly it. We are bystanders to the beauty, but we get to experience the resonance of it fully.
Which leaves me with a final thought I want to throw out there for you to mull over.
I love a good final thought. Let's hear it.
If our deep neurological sense of what sounds beautiful is so heavily shared with a tiny frog or a fruit fly,
Right.
what other human experiences might secretly just be ancient animal biology waiting to be uncovered?
Oh, that's a big question.
Think about it. What about our taste in visual art? Or the specific colors we find soothing when we paint our living rooms?
Right. Are we just reflecting sensory biases?
Exactly.
Yeah.
Or what about the way we dance? Are we just remixing millions of years of animal mating rituals on the dance floor, thinking we invented all the moves ourselves?
Oh, man. That is certainly a deep dive for another day.
It really is.
But it will definitely make you look at a modern art museum or, a crowded nightclub in a completely different light.
It really, really does. Well, thank you so much for joining us in the Deep Dive Lab today. We hope you enjoyed unraveling this scientific mystery as much as we did.
It was a fascinating journey.
Absolutely.
Yeah.
Don't forget to follow and subscribe for more fascinating stories that connect the dots of our incredible universe. Until next time, keep your ears open and enjoy the symphony.